So last class we developed the beginnings of our theory, of our consumer theory, or our model of how consumers make decisions. And our goal today is going to be to find a rule for how consumers choose how much to demand. And this is going to be similar to our rule for firms, in that firms have to set marginal revenue equal to marginal cost to maximize their profit. Consumers will have a similar rule for how they can maximize their utility or maximize their, loosely speaking, happiness. First, before we go on, I want to emphasize that today we're trying to build towards a graph and using our budget constraint and our indifference curves and our graphical framework from last time to analyze consumers' decisions and derive a demand curve. But to get there, most of the work needs to be done with equations and our intuition for how consumers will think. We really can't, the graphical approach really doesn't make any sense when you're first presented to you, so I think it's important to emphasize the analytical version first, and at the end of the lecture and in class we'll work mainly with graphs, which is what you'll see on the problem sets and tests. So the goal for our consumer is going to be to maximize his utility. Just like with our cost function and our revenue function, the idea of a marginal change is going to be very important to finding the maximum. So we define our marginal utility. It's the increase in utility you get from consuming one more of a good. It's important to note that the marginal utility from consuming more pizza will be one number, and the marginal utility from consuming one more soda will be a different number. There's different margins for each good, so there's different marginal utilities for each good. That's why we take pain to emphasize this little subscript, the marginal utility of X, because if we don't specify what good we changed at the margin, then we don't have a meaningful, useful concept. So we have two goods, P for pizza and S for soda. If you spend, and we want to think about allocating our last dollar, our marginal dollar, we can spend it on either pizza or soda, or we can flush it down the toilet. For simplification, we assume these are the only two goods that exist in the world. If we spend the $1 on pizza, how much utility do we get? Well, for starters, we're going to get the marginal utility from consuming pizza, from consuming one more pizza. But if we only have $1, then we don't get a whole pizza necessarily. A whole pizza might cost $5. What we get is a fraction of that pizza, and that fraction is 1 divided by the price of the pizza. So if a pizza is $5 and we only have $1, then we'll buy a fifth of a pizza. Similarly, if we spend $1 on soda, we get the marginal utility from consuming a can of soda, but we only get to buy one fraction of that soda. If we have $1 and a soda costs $2, then we get 1/2 of a soda, and in general we'll get 1 over the price of the soda cans. So we have two expressions now, one for the value of spending $1 on pizza, that's marginal utility of pizza divided by the price, and we have another expression for the value of spending on soda, marginal utility of soda divided by price. You might want to pause at this point and go over the logic of these two in your head, because there's going to be a lot of steps in deriving our rule, and it's not all going to click the first time. No matter how smart you are, it will take a few passes to get things to click. Probably sometime after class is over and you're doing practice problems. One of our main assumptions that we'll maintain throughout the course is that there's diminishing marginal utility to consuming more of any given good. So the first slice of pizza will taste great, the second slice may be still good, third, fourth, fifth, eventually it's going to really start to decline and maybe even become negative where we don't really want any more pizza. In practice, though, we'll assume that since you have the option of not eating the slices, the lowest the marginal utility can get is 0. So I've graphed marginal utility of pizza divided by the price of pizza. Here, it's just a declining curve. The shape really isn't important. And it represents the value of consuming that pizza, spending dollars on that pizza. And I've graphed it as a function of pizza. So the more pizza we consume, the less marginal utility we get. Now I want to add to this graph the marginal utility in blue, or the value of spending our dollars on soda. and that from our last slide is the marginal utility from soda that we get from soda divided by the price of soda. That doesn't depend on P typically as it changes. We'll just assume for simplicity. So in that case, we're just going to have a straight line here. If anything, it would increase. It's most common for it to increase, but we'll just assume that they're unrelated. So we just have a straight line. It's a straight number. And this graph gives us our intuition for our golden rule. If we choose a P here, the first blue mark I've made, we get more value from spending on pizza than on soda, because the black line is higher than the blue line. So what we should do is spend $1 less on soda and $1 more on pizza, and move in this direction of increasing pizza. And that'll be true for this point and this point as well. As long as the value of spending dollars on pizza is above the value of spending dollars on soda, we're going to want to move to the right. At some point, though, for instance at this point, the value of spending on pizza is below the value of spending on soda. So we really want to spend less money on pizza if we're at this point and move to the left. And that'll be true for all these points where the black line is below the blue line. So there's only one stable point, and that stable point is where the value of spending on pizza and the value of spending on soda are equal. There's an equation on the next slide. On the left we have the value of spending on pizza, on the right we have the value of spending on soda, and this is our rule for consumer. But for whatever traditional reason, the class wants you to memorize it in this form, to rearrange it so that the prices are all on one side, PS over PP, and the utilities, the marginal utilities, are on the opposite side. So MUS over MUP. Furthermore, you would think that the right-hand side would be called the marginal utility ratio, something like MUR. But we actually call it the marginal rate of substitution, the MRS. The book has a good explanation of why we call it the MRS. I think it's actually confusing and would be better called MUR, but you're stuck with the decisions made by Greg Mankiw. This is the golden rule we want you to memorize. MRS, or ratio of marginal utilities, equals the price ratio. Specifically, well, it's not really important which is above, whether the S or the P are on top, but it will influence how you'll want to draw the graph. So the one that you put on the vertical axis is the one that you'll want to have on the denominator here, and the one you draw on the horizontal axis is the one you'll want to have in the numerator. So now that we have our golden rule for consumers, we can move on to applying this on a graph. On our graph here we have consumption of S on the vertical axis and consumption of pizza, or P, on the horizontal axis. And we can label some points here, like this point here we'll call A, and this point here we'll call B. The budget constraint, as you'll remember from class, has the same slope as the price ratio. So this slope here represents the price ratio, and the marginal slope and the marginal utilities, the ratio of the marginal utilities, the marginal rate of substitution, is the slope of this indifference curve at any point. We can see that at point A and B, by drawing in the slopes, the marginal rate of substitution, and highlighting the slope of the budget constraint, that our marginal rate of substitution is not equal to our price ratio at either of these 2 points. So A and B are not optima. We can cross them out. If we want to have an optimal point, we're going to need the indifference curve to have the same slope as the budget constraint. A point like here, C, where the slope of the indifference curve and the budget constraint has the same value. We'll work more on this in class. It's going to take a few passes to really cement our understanding of these concepts. But I'll leave you with a few review questions that'll prepare you for section. First, explain the rule for consumer optimization in words. Try to get the intuition for why we want MRS equals to price ratio. Second, explain intuitively and using our rule for consumers why A isn't an optimal point in the graph below. And third, answer this question. At the optimum for the consumer, does the marginal utility from pizza and the marginal utility from soda have to be equal, or can they be different?